everyone, my name is Ahlam. And before I start anything, I want to have a little chit-chat. Have you ever thought about defining the universe? Well, if you didn't, it's okay. The scientists already did. Einstein defined the universe as a river that can go slow and go faster. And then other scientists came and said, hey, you know what? We can add to this. This river can fork into many other rivers, making the parallel universes. Ladies and gentlemen, let me introduce you to the multiverse. The multiverse is a hypothetical collection of parallel universes, diverse and identical to ours, and we are included in this multiverse. Well, in other words, we can say that this multiverse is a parallel universes that carry different versions of you, copies of you, let me say, variants of you. Well, we're not the first people to think about the multiverse as a theory or something like this. Marvel Cinematic Universe already brought this idea into its movies and TV shows. For example, we have the TV show Loki that was released last year. Was talking about this man, the main character, Loki, managed to meet his other variants. This girl variant of him and an alligator variant of him. I'm not sure if this is right or wrong. Well, and the box office movie, Spider-Man No Way Home. Well, the main plot that this man, Doctor Strange, a magician, or let me say a wizard, managed to get the gathered three Spider-Men from 3 different universes. And these variants of the Spider-Man came out of portals, which is like a magical gate. Well, you'll be thinking, okay, that's very nice science fiction and magic stuff. Does this align with this not science? Well, no. Let me tell you that it's proven scientifically in the science of quantum physics. In this presentation, we're going to discuss several topics concerning the quantum physics. We'll start with the rise of quantum physics. Then we're going to have a look at the Schrdinger equation, then the mystery of the Schrödinger's cat, and we're going to have a look at the quantum entanglement, and at last, we're going to have the philosophical approach of the quantum physics. We can't talk about quantum physics without talking about this man, Max Planck. Max Planck was the first scientist to talk about the quantum physics and write the first word of quantum physics history. Well, Max Planck discovered the quantum theory. The quantum theory is the theoretical basis of the modern physics, the relativity and the quantum physics we're talking about right now. He said that the quantum theory is a way of investigating the matter and the energy around us in atomic and subatomic way. Well, upon this theory came Einstein in 1905 and conducted one of his most important experiments, the photoelectric effect, where he discovered that the light consists of particles called photons. The photons is the quanta of of the light. Well, very nice. He took the Nobel for this. Great job, Einstein, but the other scientists weren't really happy. According to the other scientists' experiment, they found out that, you know what, the light is waves, and we all know that the light is wave. How come you're saying that the light is particles? Well, they did the double slit experiment. An old experiment, they redo it, and, well, the double slit experiment consisted of, we have a gun full of photons, and these photons is going to go through these 2 holes, making whatever the shape they are going to do. So they made the experiment, and they were observing the experiment as it goes. And of course, just like Einstein said, it makes 2 rows. That meant that the light consists of particles. But then they stopped observing this experiment, and they start doing it without looking at this experiment. Well, they left it and went to have lunch or something, and then they came back and found it made this pattern. This pattern, 5 rows out of 2 holes? Well, yes, just like the other scientists said, when they were not looking at this experiment as it goes, the light acted like waves. Well, they concluded that the light, when you're looking at it, it acts like particles, and when you're not looking at it, it acts like waves. Is the light shy? Is the light embarrassed or something? Well, there were more important questions to be asked. Is the light the only thing that does this? Well, no. They found out the electrons does this too. And not only the electrons, but the whole atom does this too. was magnificent and mind-blowing. How come the scientific community was so crazy about it and they start getting so much nonsensical equations and explanations for this? Until one scientist stood up and said, hey, you know what? I have an equation for this. The Austrian scientist Schrdinger, he came up with an equation, this equation. Of course, we're not going to discuss this equation mathematically. That would be so boring. So we're going to visualize it in a light way. Let's say we have an electron. This electron, whether it goes to the right or to the left. And we have a box on it, so we can't really see what's happening inside this box. According to the Schrdinger equation, he says that this electron will go to the right and the left at the same time when you're not looking at it until you take the box off. This electron will choose whether to go to the right or to the left. Again, the science community was in a mess and they didn't like what is happening. A lot of them started to get nonsensical equation and explanation for this until he did another thing. Until Schrdinger stood up again and said, you know what? This time I don't only have an equation. I have a whole experiment. The Schrödinger's cat experiment. Well, it's not really an experiment. It's like a thought experiment. It's not real. Well, this is the experiment. Let me tell you what is the experiment saying. Let's say we have a box. And in this box, we have a Geiger counter and a lethal substance. The Geiger counter is basically a detector for any decay from this substance. Well, and this Geiger counter has a hammer attached to it. So, what will happen? We say that when the Geiger counter detects any decay from this lethal substance, it will vibrate and then the hammer will go down, break the substance, and eventually the cat will die. Well, according to the quantum physics, or let me say the Schrödinger equation, when we were not looking at this experiment, what will happen? Well, just like the electron, this substance will be activated and not activated at the same time, which will make the Geiger counter detect a decay and not detect a decay at the same time, which will make the Geiger counter vibrate. So the hammer will break the substance and not break the substance at the same time. So eventually, this cat is going to be alive and dead at the same time. Well, this is so unlogical, but it's proven scientifically. And a lot of scientists didn't like it, and there's a lot of theories opposing this quantum physics thing. But just like us, Einstein didn't like this alive and dead at the same time thing, and he hated it and he wanted to prove them wrong. Just like we said, he wanted to prove them wrong. So he came with an experiment again. He said, if I have two boxes, and I have two gloves, right-handed glove and left-handed gloves, and I put them in this box, and then I will take a box and go away from this the other box, and I open it. When I found in it the right-handed glove, this means that all this period, this was the right-handed gloves and this was the left-handed glove. Well, what's the experiment in this? This is nothing. This is so logical. Well, no. Niels Bohr said, hey, you know, this is wrong. When you have two boxes and you have two gloves, and we put the two gloves in these two boxes and we take one of the boxes just like Einstein said and went to other place away from this box and we open it. All the period when these two boxes were closing, the glove inside it was left-handed glove and right-handed gloves at the same time, just like the electron. And once you open the box and you get one of the gloves is out, it will choose whether to be the right-handed glove or the left-handed glove and then send signals to the other glove saying, hey, I chose the right, you be the left. Well, of course Einstein was the right one. That can't be true. Well, no, it is true. And Niels Bohr, according to the quantum physics, was the right person and there was the right opinion in this experiment. So from this experiment we conclude the quantum entanglement. The quantum entanglement is this invisible and mysterious connection between the two electrons and the two atoms, or every two atoms. There's invisible connections between them that we don't understand. And this invisible connection is what quantum physics is kind of trying to explain it. You must be thinking, how does this quantum physics thing align with the multiverse? Well, Let me tell you, there are two explanations for this. Let's start with the docoherence. The docoherence says that when, let's say I'm made of two atoms, and these two atoms, when you're not looking at me, they act differently. So, when you have a box on me, you can't see me, and these two atoms will start to act differently. When they make another version of me, the first version will be without a head, and the other version without a heart, and the other version without a brain. So this means that all my versions are dead. So, and this only version, the one that you can see right now, is the only correct versions between all of those. So it makes our universe stable, and it kind of makes sense right now that all the other versions are dead. But then, just like I told you, that docoherence is a very weak explanation. There's another very strong explanation in the quantum physics, and most of the scientists believe in this one, the many worlds interpretations. This explanation says that when I'm made, just like we said in the docoherence, I'm made of two atoms, and when these two atoms start acting differently when you're not looking at me, they will start doing another versions. But these other versions, let me say, this other version will be a genius, and that other version will be a celebrity, and this will be a doctor, an endless number of versions. They are expanding every time you make an emotion or you take a decision in your life. They start to act differently. So this means that in the many world interpretation explanation, that we have a lot of variants of ourselves living a whole different life, but the only common thing, that we are the same person. Well, at the end, of course, I would like to explain this whole quantum physics in another way. Let's say our universe is like a bubble, and this bubble keeps expanding to another bubble, and this bubble keeps expanding to another bubble, making an endless bubbles like foam, just like Stephen Hawking referred to it. We live in a world like foam, full of bubbles that some of them die and explode and others expand. Lastly, of course, you have a lot of questions going on in your mind right now, but I will ask some of them. First of all, do we fully understand the quantum physics? No, we don't. And there are a lot of questions that the scientists couldn't really answer it, and there are a lot of mysterious things going on in the quantum physics thing, and till now, we are trying to work it out and understand our world and universe better. Is quantum physics real? Well, yes. There's proven scientifically that the quantum physics is real, and it's been used in a lot of other fields, like the quantum computing, which is a very developed way of computers that do many complex equations. Do we have variants or parallel universes? I don't know why would someone ask this at the end of my presentation, but it would be a waste if there's not a parallel universe. This magnificent and very wide universe, and we don't have other parallel worlds, that would be a waste. Was it worth hearing you? Well, that would be so rude to ask, but I hope it was informal, that you gain more information from me, new information from me, and I hope you have a very good day. Thank you for listening.